Okay, so yesterday we looked at doing scatter plots for bivariate data. So remember, if we're doing a scatter plot, we have two numeric pieces of information. So we said we might have height and we might have weight. That could be an example. And remember, this is the response variable and this is the explanatory variable. So we got a scatter plot, whatever. And now we're going to look at interpreting that. So what does it tell us once we've done the scatter plot? So we are now going to look at interpreting the scatter plots. So that's the main thing we look at in general maths. We want to get the data and then tell the person or tell whatever we're looking at it for, what does that data show us or tell us. So the first thing you're going to look at for the scatter plot is the form. So if you look here, we said the form. So what the form means is, like, if you've got over here, so we've got the dots, and if we say they're generally following like a straight line pattern, we would say that they're linear. Okay, so most of yours are going to be linear, but say for example, if our dots might look like, so we might have some dots scattered and it looks like that. So can you see that the general pattern, it looks like that? So it's not really following a curved line. That's when we say it's non-linear. Okay, so you just have a rough look at it, and we do test later on next year if it's linear or non-linear accurately. But you guys, you just have to have a general look, and most of them are going to be linear. So the next bit we look at too is we decide whether it is the direction. So are those lines going in an upward gradient, upward or downward? So if your dots are going like that, that's a positive, wouldn't it? That would be a positive gradient. So you would say the direction of this graph is positive. And then if you had a negative one, so your dots would be going down like this, we'd say the direction was negative, so we can see the lines going that way. Okay, the next thing we look at is the strength. So the strength is how close are those dots to forming like that straight line, if you think about it. So if we have, say for example, we've got dots like that. So you can see if you put your straight line of best fit in there, there's fairly big gaps around it. If I drew one like, if you saw a scatter plot like this, and you've got your dots, say they're a bit more, see how they're closer to what you would say your line of best fit is? Yeah. So this one is more of a stronger, this one's stronger relationship between the two variables than say this one's a bit maybe moderate or weak. So we've got a couple of examples here to show you down here, and we also have a value that we can find, and that will tell us exactly what category strength to put it in. Okay, so when we're actually going to look at the strength and give an accurate reading, so we're going to say whether it's weak, moderate or strong. They're the three categories. So what we can use to categorize it or to know which one it is we can use this correlation coefficient, which is the R value. So they use the letter R to represent that. And you might see the word, they might just use correlation coefficient. They might say use that to determine. Sometimes the guy who invented this was called Pearson. So you might see Pearson's correlation coefficient to tell you. Now we can find this value on our calculator. So I'll show you in a minute how to do that. But so you get this R value. Now if you have a look, if you have a R value of 0, can you see that the dots are all everywhere? There's no pattern there, is there? So a 0 means there's no strength. There's no relationship, we generally say. Can you see when they're in a perfect upward straight line, the R value is 1. We would say that's a perfect positive relationship. And then if it's in a perfect negative, it gets an R value of -1. So in between positive 1 and negative 1, you've got all your numbers. So if you look down here at this positive 9 one, see how it's fairly close to fitting all onto a straight line there? That's a strong relationship. There's something really going on with that affects the other one. So, but it's positive, so it's a 0.9, so it's close to that 1. If you look over here, this one's negative 0.7, so it's getting close to negative 1. So you can see they're close together, and we would still probably class that's like a moderate strong. But how do you know? Well, that's on this next page. I'll come back to the calculator. It's where we put the lists and spreadsheets. So we're going to go into lists and spreadsheets. And remember yesterday, we went into lists and spreadsheets, and then we put our 2 lists in. Do you remember that? And then we used that to create a scatter plot. Well, while we're on this page in lists and spreadsheets, we are going to go get the R value. And the way we do that is you're going to... I'm just going to write the commands up here. So you're on this screen. You're then going to press menu. You will then go to statistics. And then you go to stat calc. And then you would go to, you're looking for lin reg. And we want the one that says A plus BX. And then you click in, and then the instructions are over here showing you what to do. So once you've done that lin reg, you'll get this. And you'll have to put in your X list, which is essentially the EV for us. And then you put your RV in there. So yesterday when we did that example, we would have had test 1 and test 2 in there. And then you just simply put those 2 in, and you click OK or enter. And you'll get a whole list of different things. And the things we're going to look at are mainly going to be this A value, the A value, which is here, the B value, A, B, and R. We'll show you. So I'm going to just pause this for a second and show you on the actual calculator. Okay, so we've just looked on how to get the R value. So we found out with our test 1, we found our R equaled 0.9. So if we... Here's how you can categorize it. So see before we had a 0.9. So see how it would be a strong positive. And then we had a negative 0.7. Wouldn't that fall into this category? Yes? So that makes it a moderate negative relationship. So how do we get that R value to our next page? Our test 1 was up here. So when we compared T1 and T2, we found that it was now we're going to say strong. It was positive, a strong, positive, linear relationship. So when I said ask you to describe the scatter plot, we said you had to tell us the form. So there's the form. You had to say the direction. There's the direction. And then you also had to say the strength. So I've done those 3 things, haven't I? So that's all you have to write. You can even dot point it if you like. If you want to describe it, they say describe that scatter plot. I don't even care if you write form equals linear. Strength equals, what was it? Strong. And direction, positive. That's all you have to really do. You don't have to write a big blurb out. We don't read that. We look for those words and that's it. Okay, so here's what I said before. That R value can sometimes be known as Pearson's correlation coefficient, and it is the measure of strength. So a couple of factors. The variables must be numeric. So see how we had height and weight, they're both height and weight, they're both numeric. And when we had a test score, test 1 and test 2, they're both numeric variables. Now the relationship has to be linear. So when you look at it, it's no good getting an R value for something that does that, okay? It has to be looking like it's following like a straight line pattern, okay? Most of yours will be. Next year it'll be a bit different. And you can also have no outliers, Because what they mean by that is when you have your scatter plot like this, and say you got your like that, and then all of a sudden you got one down there, right? So see that this is an outlier. Boys, when they calculate the R value, what they're doing is they're taking into account all these little distances from the dot, and then they balance it out. If you had this, what your actual line will probably do, they'll probably direct it out that way, yeah, to try and get closer to that dot. So then in the end, it'll look like these are, and the R will become weak. So even though it's a very strong relationship, we just had an oddball out there. So you can't, so sometimes they might say, find it, calculate the R, then they might say, why is this inappropriate? And you'll go, because it's an outlier. Yeah, so it would affect it. And that's all you ever get asked, really. Why? They might still ask you to find it. So you find the R value, you state it. What's wrong with it? Why shouldn't we use it? It looks like there's an outlier there, okay? All right, you're going to do today, work on 7C and D, and then Friday's lesson can be used to do E, but you've got all the theory now to cover you for those, okay? Off you go.